Good afternoon, student. This is lecture number 10 of unit number 2, that is Introduction to Instrument Characteristics. Up to previous lecture we have studied what is characteristics, what is static characteristics, what is dynamic characteristics. In static characteristics we have studied what is range, span, calibration, then errors, then we have studied drift, hysteresis, types of drift. Okay, today we are going to study another static characteristics, that is sensitivity. Okay, what is sensitivity, that we are going to study in today's lecture. Okay, so basically that static sensitivity is nothing but the output upon input. Now that output is nothing but the after giving certain input to any instrument, whatever the output response given by instrument in terms of signal. Okay, and that change of output signal upon change of input signal. Okay, means that is static sensitivity is nothing but the ratio of change of output signal to the change of input signal, and it is represented by delta theta suffix o divided by delta theta suffix I. Okay, now sensitivity, the ratio of magnitude of response to the magnitude of quantity being measured is called as sensitivity, and that sensitivity is represented or denoted by capital K. Is it? Are you getting it, everyone? That static sensitivity is the ratio of change of output signal to the change of input signal, that is delta theta CO by delta theta I. Okay, now sensitivity is represented by the slope of the calibration curve if the ordinates are expressed in the actual unit. Okay, in this graph on x-axis there is a input theta I, and on y-axis there is a output theta O. Okay, now here that slope, in mechanics or in physics you have studied as the line passing through the origin and proportionate to the x-axis and y-axis, then whatever the slope we have obtained for that particular line, that is nothing but the tan theta equal to opposite side upon adjacent side. Okay, is it? Opposite side upon adjacent side. So in this case we can observe that slope as this is the line, and the line one slope. Okay, here is the angle theta, here is angle theta. Okay, now here slope is nothing but tan theta equal to opposite side. Opposite side means what? This is the opposite side, and adjacent side means what? This is the adjacent side. Okay, so that's why here slope is getting k equal to tan theta O upon tan theta I. Means what? Static sensitivity k equal to change of output signal upon change of input signal. Okay, then sensitivity of an instrument should be high, thus the range should not be, just a minute, I will have to refresh it. Okay. The sensitivity of an instrument should be high, and thus the range should not be high in comparison to the value being measured. Okay, then inverse sensitivity or a deflection factor or a scale factor. That inverse sensitivity means what? It is nothing but the reciprocal of the sensitivity. Means what? That static sensitivity k equal to tan theta O upon tan theta I, or what we can say that delta theta O upon delta theta I. Just take the reciprocal for the inverse sensitivity means inverse sensitivity or deflection factor or scale factor is equal to delta theta I upon delta theta O. Okay, that is nothing but the inverse sensitivity, or we can say that the inverse sensitivity is nothing but the reciprocal of sensitivity. Okay, for example, the operation of the resistance thermometer depends upon a change in resistance to the change in temperature, and as such a sensitivity will have unit of ohm per second, because resistance is measured in ohm and the temperature is measured in terms of degree Celsius. That's why the what we can say that that's why the sensitivity for that resistance thermometer will be ohms per degree Celsius. Okay, so that is nothing but the sensitivity, or we can say that the static sensitivity. Okay, we have explained with the help of graph, that is static sensitivity for linear and non-linear instrument. Okay, then next there is one numerical asked on the static sensitivity as well as the um, deflection factor. In a Wheatstone bridge, a change of 6 ohm in the unknown arm of the bridge is required to produce change in deflection of 2.4 millimeter of the galvanometer. Determine what we will have to calculate the sensitivity and deflection factor. Okay, now what is given to us, that is magnitude of change of output. Magnitude of change of output is response, that is equal to 2.4 millimeter, and magnitude of input is 6 ohm. Okay, so sensitivity equal to output is 2.4, and input, how much input is given, that is 6 ohm, means it will come out to be 0.4 millimeter per ohm. It is nothing but the answer of sensitivity or static sensitivity. Then deflection factor, just make the reciprocal of sensitivity, that is 6 by 2.4, and it is coming out to be 2.5 ohm per millimeter. Okay, so it will be the answer for both the question. Sensitivity is 0.4 millimeter per ohm and deflection factor will be 2.5 ohms per millimeter. Okay, so everyone will understand how the calculations are done here. Okay, then next we will have to study the threshold and resolution. Okay, now for understanding that what is threshold, we just take the use of one diagram. Okay, here suppose there is one instrument or any measuring instrument. In that instrument, one measuring scale is along this curve. Okay, along this curve, and pointer is provided here. Okay, pointer is provided over here, and one regulator is there, and regulator we will have to rotate in clockwise direction. This is 0 and this is up to 10, or we may call it as a 0 ampere, 0 ampere to 10 ampere. Okay, now we have one instrument. uh, in that case we will have to measure the current flowing through the instrument, or current flowing through the instrument. Okay, so in that case what we will do, we will just move the regulator of that instrument from 0 to 10. Okay, now when we are moving that pointer from 0 to 10, in that case we will have to give certain input to the instrument. Okay, now we are putting some values from 0. Okay, so we are increasing the input from 0, in that case what will happen, uh, we are expecting, we are increasing the input from 0 to 1, so that the pointer of the instrument must show the certain deflection on the display. Okay, but but from 0 we have increased the value from 0.1, means 0, then 0.1, 0.2, gradually we are increasing from 0, but that pointer will not show any deflection for the increase of input from 0 to 0.1, 0.2. Okay, so we are gradually increasing for a extent of 0.3, the instrument will not show any deflection, or pointer will not show any deflection on the meter. Okay, so just we increases the input from 0.3, the pointer start showing certain deflection on the meter. Okay, means what, we are we are rotating, or we are giving the input to the instrument with the help of regulator. Okay, so up to up to means from 0 up to 0.3, the instrument will not show any, instrument will not show, or pointer will not show any deflection in the instrument. As we increases from 0.3, the pointer starts showing certain deflection. Okay, and that value of 0.3 is nothing but the, is nothing but what, is nothing but what, it is the threshold. Okay, are you getting it everyone, what I am saying? Means we are increasing the input from 0, we are expecting that the pointer will show the deflection as we are increasing the value from 0 to higher value, but up to a certain measure, pointer will not show any kind of deflection, and at a certain extent, and that certain extent in this example we are taken as a point 3. Okay, point 3 means we reach from 0 to point 3, pointer will not show any deflection, but as we are increasing gradually from point 3 in the up to higher range, in that case the pointer start giving the deflection. Okay, and that point 3 is nothing but the threshold. Now we will understood with the help of this uh, definition given over here. Okay, now when the input signal to an instrument is gradually increased from 0, there will be some minimum value input before which the instrument will not detect any output change. Okay, means from 0 to some minimum value, pointer will not show any change. Okay, and this minimum value is called as a threshold of that instrument. Okay, this is one definition. One another definition is there, the minimum value below which no output change can be detected when the input of an instrument is increased gradually from 0 is called as threshold of the instrument. Okay, means what, for a minimum value uh, above 0, the instrument will not show any reading, or the pointer will not show any kind of deflection. Okay, as uh, we have increase from that minimum value to higher value, the pointer will just start show the deflection in the instrument, and that minimum value above which the instrument will give the uh, some output, that minimum value is nothing but the threshold of that instrument. Okay, and how that threshold will occur in the instrument, the reason behind the occurrence of the threshold is caused by the backlash or internal noise. Okay, so out of that few reasons we have seen in the previous static characteristics also, the internal noise, internal uh, moving components, wear and tear of the instrument parts. Okay, then some corrosion of the internal parts. Okay, so because of that the instrument will shows some threshold in the reading. Okay, then next static characteristic, that is resolution or discrimination. Okay, again we will study that resolution or discrimination with the help of see here again. There is a pointer and this is the calibrated scale. Okay. Now from 0 up to 10, as we are increasing the value from 0 to 10, the pointer is at 0, we are increasing the input gradually from 0. So the instrument will give the deflection, or the pointer will give the deflection when the value will increase from, the value will be increased from 0, value will increase from 0 and the pointer will move somewhere here. Okay, means we have rotated this pointer by a certain amount, or input by increase that input by a certain amount. Okay, so that the pointer shows the deflection up to here. Okay, now at that point the sorry at that point the instrument will not give response to further input. Okay, means we are again increasing the input, but the instrument or pointer will not give any reading. Means suppose we have increased from 0 to 2. Okay, 0 to 2, but uh, initially we have increased from 0 up to 2, the pointer shows deflection up to here. This is the input, this is input. Okay, now pointer for 2 input shows certain deflection. After 2 we are increasing the input, the pointer will not show any deflection. Okay, for a certain value, means from 2 to 3, from 2 to 3 the instrument will not showing any deflection, and as we are increasing the input above 3, the pointer starts showing the deflection. Now that whatever the magnitude of input in between 2 and 3, that is nothing but the resolution. Is it understood? Means initially in case of the threshold, from 0 we are increasing the input, pointer will not show deflection up to a certain or minimum value of input. Okay, and that minimum value of input is nothing but the threshold. And what is the resolution? From 0 the we are increasing the input and the instrument start the deflection, or the pointer will start the deflection from the 0 itself. For means for the increase in the input, the instrument start showing the deflection of pointer from 0 itself. But in between or after the reaching certain input, after that the pointer will not show any deflection for the further increase in the output, and that value is nothing but the resolution. Okay, now we will see how it is explained or defined in the resolution. When the input signal is increased from non-zero value. Okay, initially for the threshold we are increasing from the zero value, is it? And in case of the resolution we are increasing, means we have reached the non-zero value of response. Okay, is it? मीन्स काय थ्रीशोल्डमध्ये 0 पासून जेव्हा इन्क्रीज करतो तेव्हाच इन्स्ट्रुमेंट रीडिंग देत नाही, बरोबर आहे. परंतु इन केस ऑफ रिझोल्यूशन जेव्हा आपण 0 पासून इनपुट इन्क्रीज करतो तर पॉइंटर डिफ्लेक्शन दाखवतो, बट आफ्टर रिचिंग नॉन झिरो व्हॅल्यू, मीन्स फ्रॉम 0 to 2 ampere we have reached or up to 2 ampere we have given the input. After giving the 2 ampere there will be no pointer deflection given by the instrument. Okay, and uh, means we are increasing in about 2 ampere, the instrument will not show any deflection. Now after minimum input given by the instrument, then pointer will start the deflection. Okay, means after non-zero point or non-zero value. See here, when the input signal is increased from non-zero value, one observe that the instrument output does not change until a certain increment is exceed, and this increment is termed resolution or discrimination. Thus, resolution defines the smallest change of input for which there will be a change of output. Okay, this increment is termed resolution or discrimination. Thus, the resolution defines the smallest change of input for which there will be change of output, and threshold define smallest measurable input, while the resolution define the smallest measurable input. दोघांमधला डिफरन्स समजला. थ्रेशोल्डमध्ये स्मॉलेस्ट मेजरेबल इनपुट आणि रिझोल्युशनमध्ये स्मॉलेस्ट मेजरेबल इनपुट चेंज. बरोबर आहे. म्हणजे बिकॉज threshold occur at 0, threshold occur at 0 and resolution occur at non-zero. Means what? The, the static error or static characteristics threshold observed at the starting point of the input response, and resolutions occur at in between the non-zero, means any value. After 0 it will show the reading or output response, but in between 0 to the full scale reading, anywhere the input will show instrument will show the uh, resolution. Okay, so that is nothing but the threshold and resolution. Then there is one again small numerical is given. A force transducer measures a range of 0.150 Newton with a resolution of 0.1% of full scale. Find the smallest change which can measured. Okay, so resolution equal to 0.1% of full scale. Now 0.1% of full scale means what? 0.1% or 0.1% divided by 150 equal to 0.15 Newton, and this value represent the smallest measurable change in force. Smallest measurable change in the force means that 0.14 is nothing but the resolution. Okay, so this is nothing but the resolution. Okay, means what? That 0.15 is non-zero value. Is it 0.15 is the non-zero value, that's why it is a resolution. Okay, so today we have studied the two parameters. One is sensitivity and second one is the threshold and resolution. Okay, so I think both the static characteristics we have understood. Next is the precision and repeatability. Actually, in the diagram shown over here we can observe, or with the help of one archery target, you have observed in the center there is a yellow color, uh, then sorry, in the center there is red color, beside that red yellow is given, and beyond that or outside that yellow color there is a blue color. Okay, so that is nothing but the concentric circles. Okay, so as we are targeting or on the center, more points we will get. So consistently we are targeting in the center, so that is nothing but the precision. Means how 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 we can consistently targeting on the center. Okay, or targeting in the center, that is nothing but the precision. Okay, and accuracy means what? sorry, that accuracy is how consistently or number of times we are targeting the center point or eye point. Okay, and that is nothing but the accuracy. And precision means what? Anywhere in that board, archery board, anywhere in that target board, we are consistently marking at the same point or closest to the same point. That is nothing but the precision. Okay, so in the next lecture we will go in detail what is precision and repeatability. Okay, here this diagram will explain you in detail how that precision and accuracy will be understood. Okay, so here we will stop. uh, in the discussion we will discuss whatever the doubts you have with us.